A very warm welcome to everyone, also from my side. My name is Simon Sommer. I'm a cloud software engineer at copebit. And the background for my talk about reliable LLMs in production is that in the past year we had multiple clients come to copebit, come to us, and ask us about the same thing. Independently. And we were able to implement these projects. Luckily, we were able to implement these projects for each of them. Amongst them was Michael Ammann from Simpego, and he told you that they were always quick. And it was actually the case that they came to us last, but they were able to put the system in production the first. Now, let's jump right into the agenda. I'll talk a bit about the why first. I'll then jump into the main part, which is the how we did those projects. And lastly, I'm gonna show you, if the demo gods are with me, how this is gonna look like in the real world with the short demo. Let's talk about why this is relevant, why we had customers come to us, and why these projects are not super simple. The goal and the aim and the challenge was to use LLMs not like we do in our everyday life, probably, to ask a question, to get a nice answer in plain text. We wanted to use the LLMs to reliably give us answers, and to do that in a very accurate way. In a sense that they would not only always give the same answer, but do it in a structure that we would provide to them. Now, why do we even do that? Why do we want LLMs to provide structured and reliable answers? If you look at this image, and I hope it's visible from the back, it's actually it's lucky for me because I was able to take the picture myself. It's a bit unlucky for my cat because it had a quick accident and we had to visit the vet on a Sunday, which was a whole other thing. The idea was to take an image and then just be able to send it to, for example, a pet insurance company, like we've heard before. What the insurance company would need to do would be to extract the relevant information from this image I sent them. Me, as a customer, I don't want to type all these things myself, and the insurance doesn't want to have someone to look at this and then also type it out. The idea is to actually use the LLM to, from the image, extract the structured information that could then directly be used in the systems of the insurance. So what we need is to do this, basically, more or less. We need a structure on the right-hand side that is readable and processable by computers directly from the image. Again, before you would have needed to do some kind of OCR character recognition and then try to maybe regex match an invoice ID, which would not always work. With LLMs, that task becomes much easier. There are still a few challenges, and I hope to explain you a bit how you can circumvent or work against these challenges. As a concept, it's very trivial. It's what I showed you before. You get an unstructured input, you get an image, you get a PDF, you get whatever. In the best case, you just give it to the AI and you expect the output I showed you. Here it gets a bit technical, and don't worry, I'm not gonna go into linear algebra thingies here, but me personally, when I work on these systems, it always helps me to think about functions. Some of you might remember it, this notation where I would just say focus on there's an input, and also think again about the image I showed with the image, the AI, and the output. And the same is here. Think about LLMs as the function. The LLMs get an input, and by that I don't mean only the image, but I also mean the prompt, I mean system prompts, I mean schemas, everything that goes into the LLM is the input. The function, the LLM, we have no visibility. We know it's kind of a neural network and some transformer structures and some reinforcement learning on top, but we don't really know what's going on in there. So we treat it, when engineering these systems, I treat it as a very black box. We don't know what's going on. What we see, however, is when I give this input, I always get this output, or I might get this output, actually. There's challenges with thinking about these functions. You can't give almost anything to these LLMs. They will do something with it, I can guarantee it. But you don't know what, which is what I mentioned. It's very intransparent what happens in there. And you don't always get the same answer, which is the non-determinism. If you ask, and I encourage you to try, if you ask the same question twice, you get a different answer. There's good news. And that's actually why it worked with Sympego and why we were able to implement these systems. These challenges are not necessarily new since LLMs have been invented. The classic machine learning industry and approaches have dealt with this for a long time. And there are solutions that tackle this, and especially processes. Here, it's kind of, to me, this is really the heart of, and I know it's a bit wordy, but I hope that you will be able to take this away from my talk today. The main and the core idea is you define the examples and the cases beforehand. What we did was we collected hundreds of real invoices and manually rewrote what we would expect the LLM to output. With that, you get kind of and we call that a training set, that you can use to engineer the prompt, the schema, whatever goes into the LLM, except the images. You can try out different models. You can see if Claude performs better, or if Opus performs better than Sonnet, and if 4.6 is better than 4.5. And you get measures of performance of these LLMs. It's super important that when you do that, we have our 100 examples, and me as an engineer, I'm very good at optimizing the prompts and the schema towards these 100 examples. I can make the system work. I can even if I had to write, okay, if you see this invoice, the answer should always be that. I could do that. That's why after that, in steps 3 and 4, you lock whatever the engineer did. He's not allowed to touch it anymore. And now it gets tested on examples the engineer and whoever was involved has not seen before. In the best case, that would be invoices that came in after the system has been developed. That's kind of the easiest way to do it. But you could also just make really sure that they have not yet seen it before. If and only if you're happy with the result on the examples that the engineer has not seen, you can go on into production. You kind of simulate what's going to happen in production, right? Because in production, what's going to happen is you'll have cases that nobody has ever seen before. And that's why you need this approach. So first thing is having the examples and manually really write the answers. And that allows the engineer to iterate quickly and to work on these solutions. And then have a test set to figure out if production is going to work out well or if there's going to be surprises. For prompt engineering, I'm not going to talk too much about this. It's kind of an open secret by now. There's going to be so many LinkedIn posts and articles describing how to write the best prompt ever. What I would like to mention is the LLMs are also by now really good at helping you write good prompts. So it's kind of this almost ironic loop where you use the AI to instruct other AIs, but it works really well. And especially with the most recent models, they're also super smart in that you don't need to explicitly provide every single instruction, but they kind of infer from, again, maybe an identity that they are document extraction assistants and that they will work really accurately. They do a lot. What's a bit trickier than writing the prompt is actually getting the LLM to output a structured answer. And this, again, is something you don't need that. You want the LLM to answer in your language, but what we want is the LLM to answer in computer language, which these models have not necessarily been trained to do. Now, as they are by now super good at also writing structured like code, they can also provide structured answers, especially in JSON. Again, there's different ways to achieve that. If you just use something like Claude, you would kind of simulate that the LLM would use a tool. So it has to provide this JSON output, which works really well. Really recent development from Amazon Bedrock is that also Amazon helps you to verify that the JSON you wanted is really valid. How you do it is you use this JSON schema. The developers amongst you might know it well. Yes, please.
If it doesn't conform to your standards, do you just loop and say, okay, good try again, or what was your approach?
At this point, and I mean it's a pro and a con, it doesn't happen that often. So if it doesn't fit our schema, we fail. We show it to a human, which is always kind of the default. If something is not as we expected, we show it to a human.
Do you still have a human in the loop even for everything?
Especially, I mean, I won't go too much in the details there, but if anything is not as we would expect it to be, and this could also be, I'll have it on a later slide, if amounts don't add up on an invoice, for example, you always show it to a human. Yeah. For the schema, what you basically, it's super easy. You define which things need to be numbers, which things need to be dates, which elements need to be character strings. You can also define, and this was a nice case in reality, you can define which fields are required. And what we learned is that if you make many fields required and they're not on the actual invoice, the LLM would still fill in something because you made them required, right? And especially with the latest models, they're super strict in adhering to the schema. So they would just fill in something, which might not be what we wanted, to have something like unknown in the name of a recipient of an invoice. Here's just a very random collections of a few tips and tricks in case you're going to try this yourself. New models help a lot. Again, we did these projects in the past year, and if you remember the evolution that the LLMs have done within the last year, I think we started with trying these Claude Sonnet 3.5, which did not do that well. And nowadays, it's really no questions. The new models, they are almost, I really say it, almost perfect when it comes to stuff like this. Temperature is something we haven't yet talked about, but it's the part about you want the LLM to always give the same answer. You don't want the LLM to be creative and to deviate from the schema you gave. You want it to be really strict, and you can do that with temperature. Temperature basically is a way to make the LLMs more deterministic.
Do you set it to 0?
Yes. We tried with that's also nice. With the experiments, you can try different temperature values and see how the performance is along those temperature values. And yes, lower is better. We also learned that we should not let the LLMs calculate. It's really tricky because they do it super well most of the times, but they still make mistakes. If you again make a field required and they try to multiply a percentage with an amount, again, surprisingly well, but not always correct. So we try to avoid it if possible, because that's what computer and programming languages are built for. If you know the percentage and if you know the amount, you don't need the LLM to multiply them. You can do it yourself in code. And that kind of goes into your question, validate the results if possible. So if there's a way to, again, if you have an invoice and we need to add together all the amounts and see if they sum up to the final amount, we can do that in code. And we can see if the LLM actually outputted all the amounts correctly. And if it adds up, we can be also super certain that the LLM did a good job. And with that, we of course implemented that on AWS. We did not do that on EKS, but we simply did it in a very event-driven, super serverless way, where the interface is a GraphQL API that I will show you. And actually, this is you can really keep this in mind once I show the demo in a minute. What happens is the server asks the API to get a pre-signed URL so it can upload the document or the image to S3. The upload triggers the Lambda, and everything I've been talking about is up here in the red, which is why I put it there. The magic happens in there. We have a small Lambda function that basically just takes the image, puts it to Bedrock, and Bedrock, the LLM, gives an answer back. We put the answer on S3. The server can ask for responses. Once the response is there, once the LLM has processed everything, the server can get the answer. And this is more or less what I will show you now in a demo, if it works. Let's hope for the best. You see that, again, on the left-hand side, there's the invoice. On the right-hand side, and I'm thinking about, can I make this a bit bigger? Is it visible from the back? Nice. OK, cool. This is a super basic GraphQL API where we basically just send a request. We say we have a vet invoice and we have a JPEG image, which again you can see on the left. And what we want is we want a pre-signed URL back. And we also need a request ID, because the request ID, after that, we can use it to actually get the LLM response. So we send this here. And you can see the Lambda cold start for those that know it, because if I send it again, it goes much quicker. You get a response, and in the response, you get this pre-signed URL, the request ID, with a bit of Postman scripting. I put these already in the environment variables. So if I do a put file now on the pre-signed URL, we upload the image to S3, which was like the upper arrow, if you remember. What we can also do is we can use the request ID that we got back to see if there's already an answer from the LLM. If we send this now, we should get something like, OK, we got it back, but the status is pending. And it's pending because we have not yet really put the image there. So we can actually do the put file. So we upload the file to S3, and we can now ask again about, hey, do you already have a response? And it says it's still pending, it's still pending, it's still pending. Hopefully it will be processing at some point. Otherwise we do the whole exercise again. Now let's see. See the demo gods. It's still pending. Let me try again.
It's the same thing that you have to select the image again.
No, I think that should work fine. We put it. Processing, nice. Yes, and now we wait. The main waiting part is really the LLM doing its thing. So asking Bedrock for a structured response takes I mean, 20 seconds, maybe 30 seconds, you're going to see. Now it's completed. So now we send this image to the LLM, and what we get, and I can also, I can just scroll down here. We get exactly the structure we were hoping for and wishing for. This is more or less exactly what the LLM gave us. So we don't really do any post-processing apart from the checks, like, okay, do all the amounts add up or not? So you see stuff like, okay, the invoice ID is there. There's actually, I thought the same thing today, but it's the Quittung number and the Rechnung number. Yeah, I was also worried today. I was like, oh no, my demo is not going to work. No, yeah, and it actually got that correct because the Quittung is a different thing from the Rechnung. So if I ask about the invoice ID, I would be happy to actually receive this. Yeah, and a bit of GraphQL magic. I think it's super nice that you can request some of the fields and you can leave out the others if you don't need them. But you can also just really ask for them. And the answer will always be on S3. The answer is long there. So you can just request whatever you need. And you can get like really nitty-gritty stuff. And for me, that's always amazing to see. You see this kind of VAT summary where we have different Mehrwertsteuer or VAT rates, and they actually have different amounts. And the LLM is able to extract all of those numbers really to the dot. And that's more or less it when it comes to my talk. I really want to thank you. This is my cat. He's much better now. So yeah, the vet really helped in this case. Thank you.